contact. Okay, so tomorrow you're going to quiz over all 6 trig functions with any of those angles, and you'll have 10 minutes again for all of them. So like we did yesterday to help you practice for today, 10. Yeah, we did 10 today, right? That wasn't a big deal. We'll have 10 tomorrow, and guess what? We'll have 10 the next day, and then 10 more the next day, and then 10 more, and then 10 more. Yeah, but the minutes get smaller and smaller. Tomorrow's still 10 minutes. Probably so, but these are probably going to go on next 9 weeks because this Friday's the end of the 9 weeks, and we're going to have some people out, and I'm not going to give missing. So today's will probably be the first one that goes on next 9 weeks, or maybe because there's still some people out today. Well, I have to look see how many people are out, and it has to do with Mrs. Lincoln's class as well. You can just sit on my desk, Autumn. All right, so you're here just in time. We're going to practice for tomorrow. There are 2 places you can go to practice, right? The first one is Canvas, right? Everyone has Canvas. And if you go to Canvas under, I was going to do it under announcements, but I put it under modules because I don't know if announcements get buried or they go away. But if you go to the bottom on your Canvas modules, it says Quizlet using the unit circle links, UC unit circle. Okay. So there's flashcards in Quizlet. Most of y'all have Quizlet, but it's pretty good. So there's the direct link to just the sine and cosine. That's what we did today. So Autumn, that would be a good place for you to go if you like flashcards, digital flashcards. And then the one below is the direct link to all 6 of them. So you can just practice, practice, practice. Okay. It'll give you the trig function and the random angle and radians. You say it in your head or out loud, depending where you're at or how you feel. Press the button and it flips the card over and you see the answer, right? Or if you like doing things manually, you're like, I'm not going to click on a link. That's way too freaking easy. I like a challenge. You can go to Quizlet and actually type in Unicorn UC 2022. There's a lot of them out there that say Corpy's World, but apparently when you go to Quizlet, you can like copy it to your own. And so there's all different versions. So we just went ahead and cleaned it up and renamed everything. Those are the direct links. I'm going to leave that for you all to do. The other place to go, of course, for anything is your favorite website, right, Teresa? Corpysworld.com. Na, Corpy's World. And if you go to Precal Matters, because it does, right? You'll find all these matters of Precal, including, look at 5.3. Here's the blank unit circle that you'll practice with, right? Repeatedly. If you go down, here's a video of me going over the entire unit circle from the very beginning all the way through the end. If you want to watch it again or you're absent. It's a little different than the ones I have in the shared folder because this year I broke it up into 2 days. But look at this right here. Using the unit circle practice, worksheet key, worksheet key. Go ahead and download the worksheet and then upload it in Notability if you want to. That's what I'm going to do, okay? You already did it. Great. So this one has, again, there's nothing special about it. All it is just me kind of picking random trig functions first. I do the trig functions first, and then I just come back and randomly put angles behind them from the unit circle. So you can kind of create your own. But these do have the keys that are posted there. So if you look at it, it says do these in 6 minutes. These are all just sine and cosine. So you want to kind of practice, you know, at a more intense level than what you're going to be assessed. So if you could do them in 6, then you can do them in 10. But those are all just sine and cosine. I want to move on to set 2. I want to use this set 2 as a set of trig functions that'll be similar to what you look at tomorrow, but we could practice these together. Okay, we'll practice them together. Now, as we do this, I'm not going to write anything down. You will have time tomorrow to actually write the ordered pair down and manipulate the actual values that you see. Okay, so remember that the x coordinate is cosine, the y coordinate is sine. Yes, if you're asked for a secant, that's just the reciprocal of what? Cosine. So you flip the x and rationalize it possibly. If you're asked for a cosecant, that's the reciprocal of sine. You flip the y value and rationalize it possibly. Those are the 2 easy ones because you're just flipping what's there already. The cotangent and tangent are the fun ones. Cotangent is x over y. So that's where you have to actually divide one by the other. Now remember, if it's an interior angle for tangent and cotangent, which is y over x, the 2's in the denominator will divide out. Remember we did that? So really, if it's cotangent, all you have to do is take the numerator of the x and divide it by the numerator of the y, and tangent the other way around, okay? You do have to pay attention to whether it's plus or minus though. So with that, let's go through these. I'm not going to write anything down. Whatever you want to write down is fine with me. You'll have 10 minutes tomorrow. We're going to do them in 1, 2, 6, 7, just the way they're listed, okay? And then we'll slide over. All right, so secant of 2 pi thirds. Here's how I do it. I look at pi thirds first. That's the first thing that registers. Any pi thirds, I know it's going to be that taller than it is wide. So the y value is bigger. It's a 1/2 on the width, square root of 3/2 on the y. So it's some type of 1/2 square root of 3/2. I'm asked for the secant. So when I'm asked for the secant, I'm going to focus on which one, the x or the y coordinate. The x, because that's the reciprocal of cosine. So in my head, I answered the question first, what is cosine of 2 pi thirds? Okay. Well, 2/3 puts me in quadrant 2, where x and cosine and secant are all what? Negative, because I'm to the left of the y-axis. So now I know the x coordinate at 2 pi thirds is negative 1/2. I know that. Maybe I've written that down. And now comes the time to take the secant. What is the reciprocal of negative 1/2? Negative 2. I do want you to simplify your answers. So don't just put negative 2 over 1. You can, but then call that negative 2. Everyone see how we did that? We just flipped the x value. We didn't flip it off. We just flipped it. Right? Don't get that angry. It's supposed to be fun, right? You know when it's not fun? If you haven't memorized your definitions in terms of x, y, and r. That's when it's not fun. But that doesn't apply to anybody in here, does it? Hey, be honest. Thank you. You need to get there, though, right? Honest Abe, everybody. Number 2, cosecant of 7 pi fourths. Pi fourths, pi fourths, pi fourths. Square root of 2 halves, square root of 2 halves. Where does 7 fourths put me? It puts me over here in quadrant 4, where x is positive and y is negative. Okay. Cosecant is the reciprocal of the y coordinate. The y coordinate there is negative square root of 2 over 2. So all I got to do is flip negative square root of 2 over 2. Now, whenever there's a negative involved, I always get the sign SIGN positive or negative taken care of first. I break it down into 2 problems. What is the reciprocal of a negative number? Is it positive or negative? It's negative, right? When you flip a negative number, it's still a negative number, okay? When you flip a positive number, it's still a positive number. You don't change the sign when you flip a number, okay? So I know since what number I'm on? What number am I on? This one? Yeah, since I know the y value is negative square root of 2 over 2, I'm going to go ahead and write the negative down on my paper already. And now all I got to do is flip the square root of 2 over 2. What's the reciprocal of the square root of 2 over 2? Simplified? Just the square root of 2, right? We talked about that the other day. If you take the square root of 2 over 2, flip it, re-rationalize it, and then divide out the 2's, you get the square root of 2. So we have to remember that the reciprocal of the square root of 2 over 2 is just the square root of 2. Okay, now it is negative here because we're in quadrant 4. So you put those 2 pieces together quickly, and the answer to number 2 is negative square root of 2. Got it? Negative square root of 2. Boom. Number 6, pi 6. Square root of 3 halves, 1/2. 11 puts me in quadrant 4, where x is positive, but sine is negative. I want the cosecant. I want to flip the sine value. The sine value there is negative 1/2. What do you get when you flip negative 1/2? Negative 2. That's its reciprocal. Yep. So that's the answer to number 6, negative 2. Number 7, here's the fun one, finally. We get a cotangent. I like cotangent. Pi thirds, that's again your 1/2 square root of 3 halves ordered pair. 4/3 puts me in quadrant what? 3, where x and y are both negative, right? Now remember, cotangent is x over y. There's negatives involved. Let's get that taken care of first. What is a negative divided by a negative? Positive. So my answer is positive. Got it. Now remember, you don't have to worry about the 2's in the denominator when you do a tangent or cotangent because they're going to divide out. So because it's cotangent, it's the numerator of the x coordinate, which is 1, divided by the numerator of the y coordinate, which is square root of 3. Here's my symbol for square root of 3, right? This craggy hand. Well, when you get 1 over the square root of 3 and you rationalize it, you get what? Square root of 3 over 3. Very good. So the answer is what type of square root of 3 over 3? Positive square root of 3 over 3. Very good. It's cotangent. So yeah, it's the numerator of the x, which is negative 1, over the numerator of the y, which is negative square root of 3. So it's positive 1 over the square root of 3. And then when you rationalize it, you get square root of 3 over 3. You have these backwards. Yeah. Oh, you and Abe are in the same boat. Cotangent is x over y. Oh, okay. Well, you had the ratio flipped, and it could have been because you had your numbers wrong, or you could have had your trig function wrong. Yeah, there's lots of ways you can go wrong. If you, it's just square root positive square root of 3 over 3. Any questions on number 7? That's a fun one. Positive root 3 over 3. All right, slide it over here. 3, 4, 8, 9. USAA. I'm a USAA member, but I like how to say, are we exclusive? You're dang right we're exclusive, which is why you should join. You just told me I can't. They say that on the commercial. Yeah. Are we exclusive? Yes, we are. It's just for military people and their family. Are we exclusive? Heck yeah. Which is why you should join. But I can't. I'm not military. Yeah, I'm on board. I'm on board for a couple of reasons. I couldn't be in the military because I had flat feet. And I'm like, yeah, which means I could stomp the enemy a lot better. And they're like, oh, yeah, well, the rule says no. Yeah. So anyway, tangent of pi halves. Pi halves is straight up, right? Straight up. The ordered pair is 0, 1, baby, right? Not 1, 0, but 0, 1. Yeah, yeah. Tangent is what in terms of x, y, and r? Y over x. So that's 1 over 0. What's 1 over 0? Does not exist. That's what you write, DNE. You'll see that when we study the graph of tangent, we can't even put infinity down or negative infinity down because from the left-hand side, it goes to positive infinity. And from the right side, it goes to negative infinity. It's doing this. So it's not even the same infinity. So we just put DNE, but we know why, all right? Cotangent of 5 pi 6. Pi 6 is, again, square root of 3 halves, 1 half. That's the order pair. Square root of 3 halves, 1 half. 5, 6 puts me in quadrant 2, where it's negative square root of 3 and positive 1 half. Now, cotangent is x over y. What is a negative divided by a positive, first of all? A negative. I'm going to write the negative down in the answer slot. And now it's numerator of x, which is square root of 3, over numerator of y, which is 1. What's the square root of 3 over 1? Square root of 3. Good. And it's negative, right? So the answer then is negative square root of 3. It's fun. It's easy. It's getting to be fun easy. All right. Secant of 7 pi 6. Another pi 6 reference angle. Square root of 3 halves, 1 half. But 7, 6 is bigger than 1, so it's in quadrant 3 where they're both negative. We want the secant. Secant is the reciprocal of cosine. Cosine of 7 pi 6. I'm on number 8. Yeah. Right? What's the x coordinate at 7 pi 6? Negative square root of 3 over 2. I got to flip it and re-rationalize it. This is my favorite ratio on the whole unit circle. Right? When I flip negative square root of 3 over 2, I get negative 2 over the square root of 3, which when I rationalize the denominator becomes negative 2 root 3 over 3. We wrote those down the other day. Those are common reciprocals. So the answer to number 8 is negative 2 square root of 3 divided by 3. Okay. Flip the x coordinate there. The x coordinate there is negative root 3 over 2. All right, number 9, 5 pi thirds. 5 pi thirds. We want the cotangent again, right? It's one of my favorites. I know it's x over y. Let's see what the ordered pair is going to be. It's a pi thirds, right? So I know it's going to be some type of 1 half over the square root of 3 halves. I don't have to worry about the 2. So I know the answer is going to be some type of 1 divided by the square root of 3, isn't it? 1 divided by the square root of 3. It's just going to be positive or negative. Well, 5 pi thirds lives in quadrant 4, where x is positive and y is negative. What's a positive divided by a negative? A negative. So I know it's negative. And now 1 divided by the square root of 3, when I rationalize it, becomes square root of 3 over 3. Right? You want to show me how we do it here? Did you write the ordered pair down? All right, so secant. No, you're getting your angles backwards. Those should be flipped. Your pi 6 is always the wider one. It's closer to the x-axis. So it should be square root of 3 first over 2, and then 1 over 2 for the y. There's a lot of little things you can get wrong here, right? You can have your x and y backwards. You can have your ratios backwards, like if you think tangent is x over y instead. Yeah, it should be negative square root of 3 over 3. Oh, when you rationalize, don't multiply by the negative. Yeah. If you have a negative ratio, just keep it negative. It's going to be a negative, right? So again, cotangent, the ordered pair there is 1 over 2, comma, negative square root of 3 over 2. I don't have to worry about the 2's. So it's really 1 over negative square root of 3, which when you rationalize it is negative square root of 3 over 3. That's the answer. Okay. All right. And then these last two, they're both secants. What do you know about secant? It's just the reciprocal of the x coordinate, right? So let's just focus on the x coordinate for both of these. 3 pi fourths. If it's a pi fourths, I know that's easy. It's going to be some type of square root of 2 halves, square root of 2 halves. So the x coordinate is some type of square root of 2 halves. You can write down in your paper right now, square root of 2 over 2. But then you're going to flip it, right? Well, let's see what the sign is before we flip it. 3/4 puts us in quadrant what? 2, right? Where secant and x and cosine are all what? Negative, right? So I know it's going to be negative. That's the answer. And then when I flip the square root of 2 over 2 and simplify it, I get what? Or we just memorize what's the reciprocal of the square root of 2 over 2? Just the square root of 2. So the answer to 5 is negative square root of 2. Negative square root of 2. And then the last one, secant of pi. Secant of pi. That's the easy one, right? Because we're at pi, we're on the x-axis. What's the ordered pair at pi? Negative 1, 0. Secant is the reciprocal of x, of cosine. What's the reciprocal of negative 1? When you reciprocate a number, you don't change the sign. It stays negative. It's just negative 1. 1 and negative 1 are their own reciprocals. 1 and negative 1 are their own reciprocals. So because cosine of pi is negative 1, what's the secant of pi? Also negative 1. Now, we didn't have any D and E's from the reciprocal of 0, but if I asked you for cosecant of pi would be the reciprocal of the y value at pi, which would be the reciprocal of 0. What do we say the reciprocal of 0 is? D and E, because it's some type of infinity, okay? So there are two functions that are undefined at pi, okay? Cosecant and cotangent. Very good, because those are the two trig functions that are defined in terms of x, y, and r that have y in the denominator, yeah? And when you're on the x-axis, the y is 0. So any two trig functions that terminate on the x-axis are going to be undefined. What are the two functions that are undefined at pi halves and 3 pi halves when x is 0? Which two trig functions have x in the denominator? Tangent and r over x. Secant, yeah. So secant and tangent are both D and E at pi halves and 3 pi halves, okay? All right, so there you go. If you need more help with that, I'll be here in the morning. I wasn't here this morning. I had a doctor's appointment that I'd forgotten about. Thank goodness I have a wife, and so I made it. But you found other resources. I will be here in the morning the rest of the week. I can quiz you individually and talk you through this on a one-on-one basis, okay? So anyway, that's what we're doing tomorrow. And then you can practice on Quizlet, and then you got all the rest of these here. You could time them yourself, right? And you can mix them up. You could jumble them up. You can come back to them a day later and clear them and not remember what they were and try it again, right? There's only so many combinations we can make. But all the angles that I'm going to give you are going to be between 0 and 2 pi, okay? Nice friendly angles. All right, any questions on that? All right, so here's what we need to do. We need to get far enough now into sinusoids so that come Thursday, you'll be able to understand the application of the sinusoid, okay? So let's shift gears here and go back to your notes. We learned our parent function yesterday, sine of x, right? We replaced theta with x, and x was now our angle in the function f of x equals sine of x. And of course, there was a mnemonic that I taught y'all to sketch one cycle of the graph of sine of x. And it was Sahala, right? So we met Sahala yesterday. Everyone say, hi, Sahala. Hi, Sahala. Yeah, hi. She's a little shy. Hi. So what the S means sine. axis high, axis low, axis. That's what that means. So we start here at 0, 0, which is on the sinusoidal axis. Remember, we said the sinusoidal axis was that horizontal center line that runs through this wave function, right? So to sketch one cycle, axis high, axis low, and we finish back on the axis. Okay, we can't just go to the next axis points. We called that the period of this function, 2 pi, right? Which makes sense. That's once around the unit circle. So the period is the length of one cycle. So that means that every 2 pi radians, what's going to happen? We're going to stamp out the exact same thing, right? And all of those angles that match up at the same location, like this one here going up and this one here going up, they're what with each other? Coterminal with each other. Very good. Okay. So instead of going around the unit circle clockwise and counterclockwise, we're unwrapping the unit circle. Like imagine cutting the unit circle like a tire and laying it flat, unrolling it out here, and then the negatives will fall this way, right? So yeah, go ahead.
So if you like stick it off where it's 2 pi,
Mm-hmm.
moved it over to where it's 0.
It would line up perfectly. Yeah. So that's why this is a type of what we call periodic function. I mentioned that yesterday. This is third period. So every weekday during school year, we show up at the exact same time, 24 hours later, 24 hours later, 24 hours later, right? On Friday, you're going to be like, I was sitting in the same spot in the same class yesterday, right? I'm coterminal with myself from yesterday. And my Thursday self is coterminal with my Wednesday self, right? That's nice. Can an angle actually be coterminal with itself? Bless you. Yeah, it can, right? And any angle is coterminal with itself. All right. So because these were wave functions, we had some nomenclature, some vocabulary that went along with it. This was called the sinusoidal axis, the horizontal center line. But if you think of this as the disturbed wave, we define the distance. We define the distance from that center line to the top, or the distance from the center line to the bottom. We call that the wave height, or the whatlitude? Amplitude, right? Amplitude. Okay. And then we also mentioned that, hey, if this were a sound wave, if the amplitude got bigger, what would happen to the sound? Would it change frequencies or get louder? Get louder, right? So the thing that you plug your guitar in, the amplitudifier, is named after the amplitude, right? Right. Check out my new amplitudifier, dude. You mean an amp? Yep. Same thing, right? It's short for amplitudifier. We also had period, right? We defined the period to be P as the length of one cycle. How long it takes, the smallest amount of radians it takes for the graph to repeat itself. And that was 2 pi. That was once around the unit circle. What did y'all call that in your science class? The period? You called it the what? Wavelength. Yeah. And it's the same thing. And y'all use lambda for that probably. We're going to use P. P and lambda are interchangeable. It's just like, what country are you in, right? Canada. Good. I thought you were going to say Ukraine versus Russia, right? Thank goodness, right? When has the world been so unified against one particular person, right? I can't recall ever. Yeah. So anyway, what we're going to do now is we are going to learn how to sketch transformations of this new parent function, just like we've done with all of them. All right. So let's come down to this box right here, standard transformation form. It's the exact same thing we've been doing when we sketch transformations of like the square root of x, e to the x, ln of x. We have our old ABCD right there. Yeah. ABCD. A, B, C, D, then we stop, right? Oh, and now the same things apply. A and D, if you remember, are outside the function. Anything that's outside the function affects the y values, which affects the graph vertically. Yeah. If it's multiplied, it's a dilation. If it's added or subtracted, it's a translation or a shift. So A is still our vertical dilation factor, right? If A were 2, it's twice as tall. If A were 1/2, it's twice as short, right? And then D is your vertical shift. If D were +5, it's up 5. If D were yours, it would be up yours. If D were -5, it would be down 5, so on and so forth, right? Right. And then we got the inside. We got the B and the C, right? Well, that sounds like it made a good rap song. We got the B and the C. We're on the inside. I love doing math. I love doing math. Remember that trap song? Yeah. This affects the inputs. These affect the angles. These affect the graph horizontally. And these are the ones that are opposite of what they appear. B is still your horizontal dilation factor. If B were a 2, that would do what to the graph? Twice as wide or twice as narrow? Twice as narrow, okay? If B were 1/2, it's twice as wide, okay? Same thing. And then the C is also your horizontal shift. Y'all are pretty good at that. It's the opposite of what appears. So if it were X minus pi, it's right pi units. If it were X plus 7, it's left 7 units. So the same things still apply. The only thing is we have sine tucked in there, okay? Now let's come off to the side here and explicitly define some of these things in the context of a wave function. There's a little bit more vocabulary to learn. This one, I think you're going to like this one. A could be negative, right? We know A could be negative. And if A is negative, it's a reflection across the x-axis. If B were negative, it's a reflection across the y-axis. That still holds. But if we take the magnitude of A, the absolute value of A, it ends up being the amplitude of your wave, which is pretty cool, right? So if we come back up here, if I multiply sine by 2, I'm vertically stretching it by a factor of 2. So the high point at 1 is now twice as tall. It's up to 2. And the one at -1 is down here at -2. The reason it's so cool, in my opinion, is because it's still our vertical dilation factor, but it now gives us the wave height, which is the amplitude. And amplitude starts with what letter? A. A. And that's a coincidence, but it works out so beautifully. So the absolute value of A is now our amplitude. It's our wave height. Yeah. B is still your horizontal dilation factor. This one's very, very important. B is now the number of cycles in 2 pi. It's the number of cycles you see in a prescribed distance of 2 pi radians. Okay. And that's very, very important. What's the default values for A and B? 1, right? The default value for A is 1. The amplitude is 1, right? Up 1, down 1, up 1, down 1. What's the default value for B? 1, right? So by default, how many cycles do we see between 0 and 2 pi? 1. And that's why we say the period is 2 pi. Okay. Now, is B the period? If I replace that with a 2, we said that that's not twice as wide, it's twice as narrow. Does that affect the period? Yes, but is the period 2? No, but it affects the period. Tomorrow we're going to learn how it affects the period and how we can get from a B value to a wavelength or a period value. And then we're going to graph some transformations. We'll do it with sine and cosine, and you should be ready then for an application. Have a fantastic, joyful rest of the day, and we'll see you mañana, hasta mañana. It's only a day away. Doritos, Doritos, Cool Ranch Doritos.